example 4, using u substitution. So in this example, we're going to evaluate the integral sine of x times e to the power of cosine of x dx. So first off, looking at this problem, it's got a lot going on. You have sine of x being multiplied times the exponential function e raised to another trig function. So the way u substitution works is we think of what we can take the derivative of and get back something in the function. So in this example, we're going to let u equal cosine of x because we know the derivative of e to the x. So we're going to let u equal cosine of x. And so now what we're going to do is we're going to take the derivative of both sides with respect to x. And you're going to get du dx equals negative sine of x. Now our goal is to get all the x's on one side and the u's on the other. So you multiply both sides by dx. And you get du is equal to negative sine of x dx. Now, so we're going to rewrite our integral using our u substitution. So we get the integral of e to the u times sine of x dx. Notice that we have du is equal to negative sine of x dx. So we're going to multiply both sides by a negative 1 and get negative du is sine of x dx. So you see right here we have sine of x dx, and right here we have sine of x dx. So we're going to rewrite that as e to the u times a negative 1 times du. So this becomes negative the integral of e to the u du. And the integral of e to the u is just e to the u. And then plus c. So we distribute the negative and we get e to the u plus c. The reason the plus c does not turn negative is because it just represents any constant. So it doesn't matter if it's a plus or a minus. And then right before we're done, we have to substitute back for our original variable. So it becomes e to the cosine of x plus c. Now on your own, I want you to try to integrate cosine of x times 2 to the power of sine of x dx. So on your own right now, give that a try. All right, let's see what we get. So I know the derivative of 2 to the x. So if I can make my integral look something like that, I'll be in good shape. So I'm going to let u equal sine of x. So du is cosine, or du dx is cosine of x. Then I'm going to multiply both sides by dx. And I get du is equal to cosine of x dx. And I want the dx by itself. This is another way to approach it. If you can substitute right now and you're okay, that's fine. If you want to do this extra step, that's also okay. So I'm going to divide cosine of x to both sides. And I get du divided by cosine of x is equal to dx. So now I'm going to substitute everything in. And I get the integral of cosine of x times 2 to the u times du divided by cosine. And notice how the cosines are going to reduce off. And I'm left with the integral of 2 to the u times du. And when you integrate 2 to the u, you're going to get 2 to the u divided by ln of 2 plus c. We have to substitute the u back, so you get 2 to the sine of x divided by ln of 2 plus c. And that's all there is to it.